Okay, just to review preserving congruence, and remember congruence means same size and shape. So same size is the main thing you need to remember. And we're just going to look at mostly translations and dilation. So translations are when we slide a figure on the coordinate plane. Dilations is when we change the size of a shape. So either it gets larger or smaller. So change in size, larger, smaller. So number one, parallelogram TU VW is graphed on a coordinate plane with the vertices at T, 3, 4, U, -10, -2, V, and W. Parallelogram TU VW is dilated. So that automatically tells us it's going to be getting larger or smaller by some scale factor. And it says by a scale factor of P, with the origin as the center of dilation to create parallelogram T prime, U prime, V prime, W prime. Which ordered pair represents the coordinates of the dilated vertex V prime? Okay, so they didn't give us a scale factor. So we're just gonna have to look at these answer choices and see which one makes sense. But remember, if you're dilating a figure by a scale factor of whatever, you're multiplying it. Okay, so we know we need to be multiplying. So if I look at my answer choices, these algebraic representations, A is dividing, sort of. It's saying -6 divided by P. That's not what we want. B is adding, saying -6 plus P, 5 plus P, which wouldn't make sense anyway. And then C, -6 times P, 5 times P, and P was the scale factor. So that would make sense because we're multiplying those points, -6 and 5, times the scale factor, and that's what the algebraic representation looks like, or the rule. And D, -6 plus 1 divided by P, that doesn't work either. So C is the only one that looks like it's right, in the right format anyway. Number 2, which representation of a transformation on a coordinate grid does not preserve congruence? So does not keep the same size. And so what's the only one that doesn't keep the same size? Dilation. And that always looks like multiplying the scale factor times your X and your Y. So scale factor times X and scale factor times Y. So that's what we want to look for. So G, the only thing that changed was Y became negative. F, multiplying 34 times X and 34 times Y. So that's probably our answer. But just to make sure, let's check the other ones. G, the only thing that changed was negative Y. Y turned negative. So that would be, that wouldn't be dilation. H, the X and the Y are being added by 34, and that would be translation. Remember, translation is the only one that adds or subtracts from X and Y value. So it can't be that one. J, the only thing that changes is they flip and the X becomes negative. So that would be a rotation. So the only one that multiplies by a scale factor is F, and that's the one that doesn't preserve congruence. Consider the dilation on the coordinate plane below and complete the table in the following sentence. So we've got our pre-image, and our image is the larger one. So we know it's an enlargement. So that means the scale factor is going to be greater than 1. That's what we know right now. Okay, so then we look at the figure, this table down here, the figure and the image. So this is our pre-image, and this is our image. So this is before and after the dilation. And so we want to figure out the scale factor. So we can fill in these blanks here, and then we can figure out what goes here, what number, scale factor. So remember, to find the scale factor, we divide new by old. And so I'm going to take, just for this first one, I'm going to take this new 1.5, my new Y value, and I'm going to divide it by the old Y value, sorry, not X, old Y value. And so that means 1.5 divided by 1. So what is 1.5 divided by 1? 1.5. So that's going to be my scale factor. So I can go ahead and fill that in here, 1.5. And we can check some others just to make sure. But to fill E prime in, that means I'm going to multiply 1.5, which is also 1.5, times 1.5. So 1.5 times 1.5. And I get 2.25. Okay, on the second one, just to make sure, I could double check that scale factor, and I could divide 9 by 6 to make sure that's the right scale factor. So since it's 1.5, whatever we do over here, we're multiplying it by 1.5 to get our number here. So if we are gonna go backwards, if I'm missing the first one, instead of multiplying, we're gonna divide. So negative 2.25 divided by the scale factor 1.5. And I'm gonna get negative 1.5. So then down to the bottom, same thing. I've got this negative 5.5. I need to figure out what the dilated version is times 1.5. So I'm gonna multiply negative 5.5 times 1, and I get 8.25. Number 5, figure ABCD is shown below. Determine if each transformation when applied to figure ABCD preserves orientation. Remember, that's the way it's facing. Direction it's facing. And then congruency is the size and shape, technically. So a dilation by a scale factor of 0.5. So that would preserve orientation because it's going to be facing the same way, but what's the only thing that changes? It's going to be the size. That's the only thing that changes with a dilation. So congruency, or I guess we could say not congruent. So we'll say not congruent, or not congruency. So it preserves orientation but not congruency. B, a reflection across the y-axis. So that means this whole figure is going to reflect across the y-axis. So instead of negative 2.5 for A prime would be at positive 2, positive 5. Okay, so it would be flipping right over. And so reflection, technically the orientation is going to change. Orientation not preserved. But is it still the same size and the same shape? Yes, so it is going to be congruent. I'm just going to put congruent. C, a rotation of 270 counterclockwise. So that would mean, say if we're looking at A, it's going to turn 1, 2, 3 times to the left. Okay, so A is going to be over here, and this whole shape is going to have turned its direction. So that means that orientation is not preserved, but congruency is, because it's still going to be the same shape and it's still going to be the same size. So I'm going to say that it is going to be congruent. And then last one, a translation, 3 units lift and 4 units up. So orientation is going to be the same. So preserves orientation because it's not turning or flipping, it's just sliding around. So if it's facing up, all of the points are still going to be facing in the same direction. So it preserves orientation and congruency because it's not going to change the size or the shape. It's the same shape, same size, it's just sliding around. Okay, the number 6, ABCD is graphed on the coordinate plane below. Point W has also been graphed and will be one of the vertices of trapezoid WXYZ. Trapezoids ABCD and WXYZ are congruent. Identify the coordinates of trapezoid ABCD and the missing coordinates for vertices XYZ in the table below. So point W has also been graphed and will be congruent. Okay, so ABCD is the same as WXYZ. Okay, so that means this point W that they gave us is proportional to A. Okay, so those are the same points, just on 2 different shapes. Okay, so let's go ahead and fill in this table for ABCD with those coordinates that they gave us. So A is at 7 and 1, 2, 3, 5, 6. 1, 2, 3, 4, 5. Oh, 5. So it's at 7, 5. And B is at 7, 1, 2, 3, 4, -4. So 7, -4. C is at 3, -3, 3, -3. D is at 3, 1, 2. So 3, 2. Okay, so if these are the same points supposed to be, and W is at -4, 5, then that means B and X are the same. Okay, so let's see how far that changed. So A just went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So point A to W went to the left 11 spots. So I'm going to say -11. So remember, if we go left or right, that's my X value. So the X value is changing by 11. Since we went to the left, it makes it negative. And then as far as the Y value goes, we didn't go up or down. A just shifted over 11 spaces. Okay, so our Y, nothing happened to it. So we could even say +0 if we wanted to. So let's see, we've got X and Y, and it transformed by -11, and Y changed by nothing. So let's figure out the rest of these. So B, if I took my X value there, 7 minus 11, -4 plus 0, my new points would be -4, -4. And then for C prime, I've got 3 minus 11, -3 plus 0. So that's going to be -9 and -3, 3 and 2, so D prime is going to be 3 minus 11 and 2 plus 0. So same thing, -9 plus 2. So just to make sure and check that this is the same shape, just translated, we can go ahead and plot these other points, X, Y, and Z. Okay, on the worksheet, the top part, true or false, just look really closely, use common sense, and read carefully. 8, write the new coordinates there, move 7 to the right, 3 units down. So you're going to be adding or subtracting from these points according to what they give you. So if it says right or left, remember that's your X value. If we go to the right, we're adding. So that would be +7. Up and down, if it says up or down, it's talking about the Y-axis, and in this case it's going down, so that's our negative numbers or minus. Okay, so that you'd go through, add 7 to each of your Y values, and you would subtract 3 from each of your Y values. Wait, add 7 to all of your X values and subtract 3 from all of your Y values.